Hi, my name is Alyssa, and I'll be talking about the usage of artificial intelligence in space exploration. Artificial intelligence is a field of study in computer science that has been making extraordinary advances in recent years. It has enabled people to solve problems faster than traditional computing could ever allow. However, these advancements are not limited to applications on Earth. Artificial intelligence could lead the way to the advancement of space exploration. Working in conjunction with scientists and developers, artificial intelligence will advance work done in space travel and space research by automating image analysis, developing autonomous spacecrafts, and creating effective communication networks. Before I dive deep into applications of artificial intelligence in space exploration, I would like to introduce some concepts that are essential in artificial intelligence. These two concepts are machine learning and deep learning. Machine learning is defined to be algorithms that give computers the ability to learn from data and then make predictions and decisions. The statistical data is used to find patterns and then perform actions based on these patterns. A prime example of machine learning is the personalization of social media feeds. These social media feeds are dependent on a multitude of factors, such as posts you've liked or posts that you've shared. The algorithm then creates a list of users to follow or posts you'd like to see. Additionally, deep learning is seen to be the next generation of machine learning, as it is designed to make their own decisions entirely independent from human intervention. In many cases, machine learning is dependent on human intervention to arrive at the optimal outcome. But deep learning models use artificial neural networks, which are inspired from our own brain's neural network, and it analyzes data with a logical structure, and is similar to how a human would draw conclusions. On the right is an illustration of the large field of artificial intelligence and the narrow and more focused realm that consists of machine and deep learning within the world of artificial intelligence. In regards to research for space exploration, there are systems in place that automate image analysis. These systems could be used to classify new planets or take a closer look at the surface of planets through the use of orbiting spacecrafts and telescopes. A prime example of image analysis is the work being done on Mars. In October 2020, NASA has found new craters on Mars from the Mars Reconnaissance Orbiter with the help of artificial intelligence, specifically machine learning. They built a tool called an automated fresh impact crater classifier. In order to train the crater classifier, researchers vetted 6,830 images of previously discovered craters from the orbiter. It also was given images of no impacts on the surface of Mars in order to differentiate images with and without crater impacts. With this process, there are some advantages and disadvantages. One disadvantage is the accuracy of the analysis. The findings made from the computers are oftentimes checked and validated by scientists and developers working on the research. Despite this, the automated image analysis cuts time on examining, searching, and investigating large sets of images gathered by telescopes or orbiting spacecrafts. While researchers analyze data on Earth, spacecrafts are often the ones acquiring and collecting a multitude of evidence to be analyzed. Spacecrafts are often controlled by people on Earth. However, there are oftentimes a lag when information is sent from Earth to the spacecraft in space, and so the development of autonomous spacecrafts are crucial since human intervention won't always be needed. With this reasoning, the recent Mars rover, Perseverance, uses artificial intelligence when landing onto the Jezero crater in Mars. Landing was dangerous as there was a river delta, steep cliffs, sand dunes, rock fields, and smaller impact craters on the site. The new AI-enabled Terrain Relative Navigation System, TRN for short, was built to assist the rover. The Perseverance rover has a camera that will take several pictures as it descends down and use the onboard map to configure a desirable landing location. It essentially uses landmarks on the landing site to ensure a safe arrival on the surface of Mars. Once landed, the system will aid Perseverance in traveling the diverse terrain and collect valuable scientific samples. Overall, the creation of autonomous spacecrafts ensures its preservation on unknown territories and lack of dependency on human intervention. Communication between Earth and many orbiting spacecrafts are vital when it comes to gathering and collecting data within our solar system. Space may seem to be a vast and empty place to have the perfect conditions for radio communications, but don't let that fool you. There are still plenty of ways to disrupt radio communications. As a matter of fact, space weather, which is caused by the sun and other celestial bodies emitting electromagnetic radiation, fills space with noise that can disrupt those frequencies. Typically, there is a reliance on human-controlled radio systems to communicate with Earth in many NASA spacecrafts. To meet the demand and increase efficiency, cognitive radio is used. Cognitive radio is an infusion of artificial intelligence into space communication networks. The use of cognitive radios are pivotal, especially beyond Earth orbit, where the environment is relatively unknown, human interference is difficult, and connectivity is crucial. Cognitive radio uses neural networks to sense the changes in environment and adjust its settings accordingly. As a result, cognitive radios, with its integration of artificial intelligence, are more resilient in unknown environments compared to traditional radios. To conclude, we've seen how machine learning and deep learning are applied in many tools for the advancement of space research and exploration. Artificial intelligence continues to strengthen and enhance space travel and space research by automating image analysis, developing autonomous spacecrafts, and creating effective communication networks. Thank you for watching.